Today here with me is Missy Cummings. Missy is a professor in the Duke University Pratt School of Engineering, the Duke Institute of Brain Sciences, and she is the director of the Humans and Autonomy Laboratory and Duke Robotics. Before entering the world of academia, Missy was a naval officer, and she was one of the Navy's first female fighter pilots. Missy has become an expert on the complex relationships required for AI robots to work alongside humans in the real world. Most recently, following an explosion of autonomous AI robotics in industries like aviation, medicine, and even in everyday mundane environments like driving, Missy has been one of the loudest voices calling for greater controls on the way AI is deployed to ensure that it is always safe. So happy to have you here with me. Welcome, Missy.
Thank you for having me. It's great to be here.
Well, thank you so much for joining us. So I got to ask you, I mean, you started out as a fighter pilot. I mean, that is one of the most unusual ways an academic could start their career. I don't know anybody else. I know no other fighter pilots, actually, and definitely no academics who've been fighter pilots. How did that come about?
Yeah, there's just a handful of us in existence today, but it came about because, I was always talented in school and good at homework. That's probably not that surprising. But when I was in my early 20s finishing college, I didn't want to do any more book learning. And in fact, I swore on a Bible in college that I was never going to get a graduate degree, much less a PhD. And, I was young and full of life and wanted to really push the limit. And the movie Top Gun came out when I was a junior in college. So it's not surprising, like a big, movie about how cool it is to be a fighter pilot. And I've always been one of those people with a need for speed. I've had way too many speeding tickets in my life. So, I think for people who know me, it's not a stretch at all to know that, sure, that's exactly the kind of person she is. I actually think the bigger question is what happened to then make me leave flying and then go back to school. And I think that, it's the age-old story of, you grow up and you mature and then you start to appreciate life, that it's a 360-degree environment. It's not just unidirectional. Fighter pilots, I have to tell you, we're the most selfish, self-absorbed. When you're a single-seat fighter pilot, you're at the top of the totem pole in the military, and everyone exists to serve you. And then, I kind of woke up and realized, especially being one of the first female fighter pilots, it was kind of put in my face that my peers didn't want me there, and the men just fought terribly to get women out. And I flew fighters for a few years, and then I just decided I needed a better environment. I needed a better life. I needed to live in a world that I felt like I was appreciated and that I was giving back to society. And that desire to pivot away from, being the narcissistic kid that I think all kids go through this phase, I just finally grew up. And by that time, I had started to see so many of my peers die. And when I flew F-18s, for the 3 years that I flew them, on average, one person died a month that I knew. And it was always the human-machine interface problem. The airplane, which has a ton of advanced automation in it, just exceeded the capability of humans, and people would die. And they still are dying because they just cannot attend. They don't have the attention. They don't have the reaction times, all of the things that you need to be a fighter pilot. You may be the best of the best, but indeed, computers are probably better when it comes to a lot of fighter pilot skills. So that actually made me sit back and say, there's got to be a better way. And that's when I decided to go back to school against all of my other swearings off and say, okay, I'm going to get my master's, PhD, and then go into the world of academia to fix what I saw and continue to see is a huge problem.
So I'm really curious when you say you saw many of your colleagues die due to a human-machine interface problem effectively. So you're saying it wasn't enemy based casualties. It was just a human mistake caused by the interface not being intuitive enough. Is that a good way to think of it?
Yeah, that's a great way to put it. I do think it's shocking to most people. I've only known a couple of people. I knew one guy that was shot down in the Iraq War, and he lived. But everyone I know that died in a training accident. So wow. It's always, there's a lot of problems with, we do these very low level missions where you're flying close to the speed of sound, very, very low on the ground. So there's zero room for margin. And even where radios and buttons and switches and dials are located, I mean, I have to tell you that there are just some days you're just like, who thought of this? Cannot possibly be a good idea to put a button in some place that's hard to reach and manipulate if you're going the speed of sound 100 feet over a desert floor. So, and that's a very basic problem. I think with the increase in automation and what we think now is autonomy and AI, where you're having to really work with the computer to understand the state that the system is in, what do you need to do to achieve the state you want it to be in. You're working with multiple sensors at any given time. It's a lot going on at one time. And indeed, Lockheed Martin would tell you that to fly the F-18, you needed to be 1.7 of a man. So, you needed to be 70% more than just one person. And so, and we would talk about that. And we'd be like, I'm 1.7 of a man. Yeah. And that's indeed why so many people were dying, is because, by the way, you're not 1.7 of a man.
Yeah, that doesn't seem a great system to be embedded in when your life is at stake. Exactly. And maybe other people's lives could be at stake as a consequence right. too. And I'm really curious about getting into that, because then ultimately you start Human and Autonomy Laboratory at Duke, which is of course trying to address a lot of the challenges there. But then as I was actually starting to read on the latest work you've been doing, first thing I did is of course type your name into Google, and I started typing Missy Cummings. And as you know, Google has autocompletes. When you type something, they think they know what you want to maybe complete your search with. And so the top completion was Missy Cummings space and then Elon Musk. Why is that, you think?
I think that's so interesting because it's possible that Elon Musk has heard my name. I can't imagine. He's so busy. I can't imagine that he really knows who I am. But I'm basically the albatross around his/Tesla's neck. And I want to be clear that I actually love Tesla as a company. I really appreciate the disruption that he's bringing to the automotive industry. And I'm 100% behind him disrupting car manufacturing and selling and EVs. I'm all behind him. And I absolutely love what he's doing in SpaceX. That being said, he relies on cool whiz-bang new technologies to kind of keep people excited about Teslas. And this is where autopilot he and I have started to cross, proverbial swords over autopilot and full self-driving. And indeed, the latest where I'm going after him is his desire to drop radar out of his cars and now go to vision only, which, there's not a researcher I know alive that does vision research who doesn't think that is crazy and going to kill someone. And so I like him as a person. I like what he's doing with his companies, but he is also, as the central point of focus and the hype driver, he's also spreading some, I think, dangerous, at least perceptions about what his car is capable of, and by proxy, what potentially other cars are capable of.
Now, that's of course, like, you're concerned about the humans in the car, but kind of double click on this for a moment. The Tesla autonomous car is possibly, it's hard to compare exactly, but it's possibly one of the most advanced self-driving cars. when we compare the different efforts out there. Yet you're very specifically concerned about the Tesla one. It seems less so about others. Can you say a bit more about why there's maybe more concern there?
Well, even Tesla would tell you their cars are not self-driving. They are driving assist, right? So when you buy a Tesla, you have to sign all sorts of documents that, where you swear that that the car cannot drive itself. So when you say Tesla does embed some technologies that maybe could be self-driving one day. And indeed, Elon has said that he wants to do a robo-taxi model and thus be able to use you can let your car drive itself and make money while you're at work, which I actually think conceptually is a fantastic idea. Unfortunately, in the practical implementation, it's a disaster. Elon Musk is not the only person who doesn't like me. John Krafik from Waymo, who just resigned from Waymo. He was always super sweet to me in person, but I can only imagine, I was a massive pain in his side when he was the CEO. And that's because I also went after Waymo and Uber and other companies when they started making claims about what their technologies were capable of. And I am 100% about innovation. I'm a professor. I'm a futurist. It's my goal. I try to generate patentable designs and inventions, just like most professors in engineering. However, I think that in the case of self-driving vehicles, and I want to step back because that's not the only area I do research in. I'm actually heavily invested in all things related to drones, autonomy as it's used in medical systems and manufacturing systems. So I look across multiple domains, and unquestionably, computer vision, while it is making a lot of progress, we are just simply not there in terms of having vision systems replace not just your eyes, but also your brain. And that's in fact where the real problem is that, you can't treat camera sensors like replacement for eyes because there's so much going on in terms of projection and imagination and judgment under uncertainty and knowledge. And we're making progress with machine learning and computer vision. And and if the car industry had not invested so much money, I've lost count of it's billions of dollars in this industry. It has been great for helping move research forward, but it's still research, and that's the problem.
So I'm really, really curious about how you would kind of articulate the distinction between what is computer vision research and what is needed to make it a commercial reality in the spaces that you just mentioned, like drones and self-driving. What makes for the big gap there?
Well, this is, we could spend all day talking about in-depth statistical manipulations, and your readers would be instantly. In fact, if you want to read some guaranteed put you to sleep papers, go to my website. There's a ton of them on there that will put you out. But I would say that the real key is the need for dynamic adaptation. So if you've got a computer vision system and there's not time pressure and you're not in a safety critical system and it's a relatively narrow application, computer vision is going to be great. My favorite application recently of computer vision is for anthropologists to use to figure out, they take pictures of pottery, of shards of pottery, and then basically the vision system with the underlying machine learning can actually help them figure out what pieces go together. That's just fantastic, right? To me, that is amazing. It's just a huge leap, and you can appreciate that, humans are good at putting puzzle pieces together, but it's also really hard for us to take, if we don't associate two things together, it's really hard for us to take disparate entities and put them together. So you can actually take all the shards from an archaeology site, and then the computer vision will do its magic. And so to me, that is the ideal application. And even in the military, they can use a lot of computer vision to analyze images. We have drones flying 24/7 all the time. And I would say probably 95% of that imagery never gets looked at after it's initially recorded. There may be some really important information in there, but we just simply don't have the manpower. So it's not time pressure, relatively narrow domains. If the computer vision makes a wrong prediction, no one dies, right? So those kinds of applications, I would say they're commercializable right now. So, and companies are commercializing them. Where we start to run into trouble is when we start to potentially use systems that are time critical and or safety critical. And so I could start talking about radiology, and this is, something that has become, I think, more and more apparent to everyone, is that if you're letting just the AI diagnose potential breast cancer, for example, you're going to kill people. So in this way, and of course, as the director of the Humans and Autonomy Lab, this is my message I'm going to say to you is I prefer in safety critical and or time critical settings that we really look at collaborative arrangements between humans and AI. How can we have AI augment humans, maybe put up some guardrails for humans so they don't, for example, drive off the road? Emergency lane assist is a great vision, narrow band that can help keep people safe. But then that fine line between emergency lane assist to help keep you safe and then letting the car drive on its own while you can have, like in the Tesla, you can be up to 45 seconds, maybe even more. 45 seconds at 70 miles an hour is a long time not to have your eyes on the road. And so that's when the use of vision starts to become a lot more questionable in my mind.
So it's really interesting. You allude to real time and safety critical, where it becomes really important for the human to still be in the loop. Well, maybe it's always important for them to be in the loop, but when it's time critical and safety critical, the human being in the loop is a lot harder, because if you have to react instantly, it's much harder than if you can react a bit delayed, right? For example, as you might know, at Covariant, we have robots that work in warehouses, and we encounter similar challenges getting to 100%. 100% reliability. That is not where you expect. But once you have many nines of reliability, all of a sudden, it's really commercially viable, because it's okay to make a small mistake once that can be fixed later, because no real-time interventions are required.
That's right.
So I'm curious, when you look at the spectrum of applications, you mentioned driving, drones, surgical. Are there others where you see this time aspect being so critical?
I think there is, where is time critical and where is it perceived to be critical? Because these are not always the same question. So time is critical in a driving scenario. In fact, I think people find it, I give a talk about how we're going to have self-flying air taxis far before we're going to have self-driving cars in unstructured settings. And that's because even though it seems to be the opposite, flying is actually lower complexity than driving, because for the most part, you don't have 50 other idiots, only inches away from you when you're flying in airspace, right? So that third dimension, even though it's an extra dimension, actually provides you safety buffers that you don't get on the road. So there, I think the time critical aspect is a defining aspect, although I just finished my sabbatical with Amazon Robotics. So I'm very, very well aware of the manufacturing. And so that's where I think you're like, well, is it really time critical, or are you just perceiving it to be time critical, right? And so this is where I think in manufacturing settings, not just Amazon, but Walmart and every other manufacturing environment, time is money. And so I think that there is a tendency for companies to start associating what is time critical. They'll put the time critical label on something when indeed it's actually not that critical. And this idea of augmenting the human, having the human come in discrete intermittent times, great. Because humans, as long as they don't need a lot of time to gather what we call situation awareness and understand what's happening, a broken robot on the floor is not an emergency ever, right? Mm-hmm. If it's stopped, good. And that's the other thing. I think companies need to really think about what is that graceful degraded state that we need to try to achieve, because the safe state, you need to be able to degrade to a safe state. A stopped robot in the middle of a manufacturing floor, with a light shining, say, help me. Okay, that's a pretty safe degraded state. What you don't want is a robot that is potentially moving and it senses that it's in a degraded state, but maybe you think that you're just going to get, maybe I have more vision, more images coming in, and maybe I can resolve the problem. Especially in these early days of getting robots to work particularly in unstructured settings, just stop it and figure out the problem and then build from that.
When we talk about understanding what the system can do, one of the things the self-driving industry has done, they've defined these levels of autonomy, right? Level zero is really nothing's at play. That's a good old-fashioned car. But then there's level 1 through 5, where there's some notion of intelligence in the car that goes up from level 1, and level 5 is the most intelligent qualification. What do you think about that?
So it's an argument that lots of people love to jump in the argument about, are these the right levels? Should we have the levels? And in fact, those levels were built off of some research levels that Tom Sheridan at MIT proposed back in the 70s about just in general thinking about humans and manufacturing robots. And so this idea of levels has been around a long time. And it's funny to me, this is how you know when you're old, as you're starting to see the trends they repeat themselves over and over again. And there was this big outcry against levels of automation for robots and drones. And now there's a big outcry for cars. I'm not emotionally invested in this argument. I don't even think it's really an argument worth having, because human brains, we just love to categorize things. We have to bend things. It's like an addiction. So you can talk about it however you want. The human brain is always going to categorize capability in some kind of, high to low, whatever that's going to be. So I am less concerned about whether or not we're calling things levels of autonomy or levels of automation, and whether that's right or whether that's wrong. I'm more concerned that we start to look at the capabilities of a system and match that against the demands of the environment, and potentially, if there are going to be humans in the loop, does that system accommodate human error? And I will tell you, I am the first person that wishes we could have self-driving cars. I've got a 14-year-old. I do not want this 14-year-old driving. She is great. I just like the idea of my daughter driving. No, I don't want it. So I would love to be able to get self-driving cars in place right now. What you said before about humans in the loop versus on the loop, the real distinction is humans in the loop are, you can imagine, like if your hands are on the wheel and you're fully paying attention and something goes wrong, even though you might have cruise control on, you are in the loop because you are engaged, you know what the position of the steering wheel is. What gets dangerous is when you move on the loop. And this is what happens in autopilot, is that the car's driving itself. It's doing a pretty good job. And, we've seen multiple deaths. And only in one case was a death attributed to a driver on a video game on his phone. The other ones, there was no obvious source of distraction. The drivers obviously got distracted, but we can't say for sure what that was. And it can just be, you can drop something on the floor of the car. You can just bend down for just a half a second to pick up your phone or the donut that you just dropped. And that's where it's super time critical. And just that momentary glance away can be enough to kill you in a car. So I think that, humans on the loop is definitely a harder problem to solve than humans in the loop. But going back to the temporal issues, and that's why you have to understand, that's why you have to design the autonomy to understand not just the environment that the car is operating in, but the environment that the human is inside that ecosystem, because that's also going to end up defining whether or not your system is successful.
So what I'm hearing is that maybe ideally, it wouldn't be exactly that, but maybe ideally there would be not levels of autonomy so much of a car in your view of how things would play out better, but it would be in some sense levels of what the human can achieve together with the car. Not sure how that would be quantified, but some notion that human and car together in this situation can achieve this level of safety, and human and car together in this kind of configuration can achieve this level of safety. And I imagine that's where a lot of your research goes, not just for cars, but in general, how to quantify the combination of human and machine and what they can achieve. So how do you do that?
You should be on my. I have a computer science student, PhD student, and you should be on his committee because we're looking at exactly that thing, exactly what you were talking about. We're trying to model the state of the vehicle. Where is the vehicle in at any given time? And then what is the state of the human? Because you can imagine that it's when the vehicle gets into, and we actually look at it as a 3-state combination. It's the environment, the car, and the person. And when all 3 of those get to a high uncertainty state, that's when you're going to have an accident. Humans aren't paying attention, low sun angle at the end of the day, and car sensor struggling to do lane detection or has some other inherent problem, and it's when all of those start to combine that you really get high risk states. So indeed, that is what we're doing for research. And it is really hard because you have to trying to model non-determinism in just physical systems is hard enough. And in humans, it's very hard because we have such wide variability. So I try not to model humans per the mean human, the average human, because that doesn't really tell you anything. What we really look at is the boundaries of human performance, like what is the worst possible state? And in a car, you have to assume that a person is not paying attention. So that is the worst state that the human can be in.
Now, then I would imagine what you actually want, instead of outward-facing cameras to the road, you want inward-facing cameras that actually catch the human being distracted and somehow get them to pay attention again, which is yet a whole other computer vision problem then.
Right, that's right. So now there are layers of vision, but indeed, even Tesla now has turned on their in-car camera to monitor the driver. So driver monitoring systems that are camera-based have been around for a long time. So it's generally accepted that in the driving community, you're going to have that information.
Now, one thing I wonder when you look at, I have a Tesla, and when I put it on autopilot, I'm here. It's done well so far, I guess, But then I look at the statistics, right? And I look at the statistics, and I'm like, okay, well, I've been in this car maybe, I don't know, a few thousand miles on autopilot, right? But the statistics is that even humans only get into accidents every 500,000 miles. So for me to personally experience it to be better than, an average human driver, that's what the statistics are, I would need to sit in it for 500,000 miles. And if after 500,000 miles, it doesn't have an accident, then I would know, actually, if I think I'm worse than the average human driver, maybe this thing is better than me. If I think I'm better, maybe I need to see a bit more evidence, right? And so I'm curious how you think about those numbers, because maybe we can never be perfect, right? With any system, even humans are not perfect, though we try to get as close as possible with everything we do. And when might the numbers be good enough that it's just like, okay, these numbers, it's better than human kind of number?
Yeah, I think that is a very tricky question because all miles are not the same. So, if you're driving on the 101 in the Bay Area, that is perhaps the most well-mapped interstate in the country for self-driving cars. Indeed, whenever I come out there, one of my friends loves to take me out in his Tesla so he can show me what idiots all the other Tesla drivers are being. And we'll just drive up and down the 101, and he loves to show me what people are doing that are crazy in Teslas. So So I think that your interstate miles, it's not surprising to me that you've never had a problem. Indeed, most people who are responsible drivers and who are using the Tesla in the way that it's intended don't have a problem. Where this starts to break down is when Teslas are used outside their operational domains that they should be in. So Tesla will tell you that the autopilot system and even full self-driving, they're optimized for the interstate, but they will still let you use it on divided highways and still let you use it in urban environments. And this is where we're starting to see problems. And this comes back to human habituation. We've known this for a long time in aviation, that automation that's pretty good is actually more dangerous than automation that's terrible, because automation that's pretty good lulls you into a false sense of security. So it makes you think that the automation is more capable. And indeed, for the people who have died, they fell into that trap, that they put more faith and more trust in the autonomy than they should have, but likely in a Pavlovian response, because the car had performed so well for them for so long. So when you ask me, is there a mile? What is give me the metric for when I know my car is safe? And I'll tell you, well, first of all, it's not some number of miles driven. It would actually have to be some number of miles driven in all those domains where uncertainty is high. So right after a rain shower, under static objects on the freeway, and we've seen Teslas ram in many times into static objects on the freeway. Indeed, I think this is one of the reasons why Elon thinks that by getting rid of the radar, he can get rid of this problem. But then there will be new problems. The white truck, the side of the truck that wasn't seen by the vision system because the system couldn't discriminate sky from the white side of the truck. So what bothers me and what worries me is that we're still almost in this, and as academia, that's kind of where you would expect. We're still learning things about this technology and where we need to fix it. And that's okay from a research perspective, because that's where we should be. But you're talking about a deployed technology that's available for commercial operation. And we should not be being surprised by technology that we say is ready to be available for public use. And Tesla would come back to me and say, oh, it's beta. We told everybody it was beta. You're driving a beta. I have a real problem with people testing their software in safety critical systems on the general public. And although I will argue, every time I'm critical of Tesla, I have to block about 100 people on Twitter, because the Teslarati just will come after you if they think that you're being critical of the car. But people, you shouldn't be testing a system, and this is true for any system. You shouldn't be using your customers to do the testing that you are too cheap to do yourself.
Now, I like your advocacy, and that's one part of what you're, of course, engaged in. But the other part is that you're actually trying to solve the problem in your lab at Duke, right?
That's right.
You are looking at how to even understand this problem, which is so hard because, machines are hard enough to understand. And now we try to understand humans and machines and together make them more capable. And humans are so much more complex than pretty much any machine, at least any machine I know. And so how do you go about it? How do you even set up a research program that involves, this complexity of studying both humans and machines and ask the right questions?
Yeah, I think that's a great question. I think if you talk to, 5 different incredibly successful academics where their inspiration comes from or how they organize their life, you're going to get, 10 different responses from those 5 academics. But I am very fortunate that it's people like Elon Musk that provide me with all the inspiration that I need. There's so many real world problems happening today, obviously in the self-driving, driving assist, that I love to pull my research questions from the world that I live in. I am definitely not a theoretician in the sense that I don't sit back and think about quarks and photons, and that's just not who I am. I am thinking about, and I'm an engineer, right? We've got technology, it's in the world, and I need to make technology safer, given the fact that we know that humans are, they can just be so unpredictable, and indeed they're predictable in their unpredictability. So trying to figure out how to bound that problem, I think, is difficult. But I just finished one project that was, it's another good example of a collaboration between humans and vision. So a couple of years ago, before COVID started, Pfizer reached out to me because they were having issues with their research fermentation units. So they actually, before they start fermenting vaccines at scale, they actually have smaller versions of that, and because they're trying to make sure that they know how to grow the vaccine correctly inside the little units so that they can scale it. And so they were having a real problem with inside these research vaccine units. And I'm not, biology and chemistry were my worst areas. So I really had to do a lot of learning to get up to speed in this effort. But it turns out you've got to have it's like brewing, by the way. It's like you have to have some foaming inside. When you grow a vaccine, you need to have foaming for the same reasons. You need to make sure that there's enough oxygen and that the cell culture is growing. And so we need foam, but too much foam can actually, it actually causes a huge chemical biological spill inside of a facility, and that's bad. And so this research vaccine fermentation foaming problem is still unknown to scientists. We don't know how to predict it. We don't know everybody's tried every statistical model on the planet, looking at all these different variables, and no one has been able to come up with a successful model. This is actually great for model-free estimation using some kind of machine learning, because we've got a sight glass, and we can actually tell as the foam grows, the vision can actually track when it might get to a place where it's going to explode in the next few minutes. And by the way, every one of these little research vaccine units, they have their own personality. So there's not one model that can apply to all of them. You actually have to train a model on each of your units. And then what we do is we loop the human in. So we have a vision system that loops into an app. So we built an app for the scientists to walk around with. And so if it was starting to creep up, and there's not a hard prediction that it's about to go, but you're starting to get into concerning areas, the scientists, wherever they are, can actually look on their phone and say, okay, or I've seen this before because I know the personality of this little reactor. So that's not concerning, or maybe it is. And in this way, the human and the autonomy, they're sharing their predictions. And indeed, that would be the next step of this research, is to see if the human and vision system working together could actually improve that over time, because we would ideally love to fully automate that. The scientists hate babysitting this fermentation unit, right? But we're just not there yet where we can get with enough high enough accuracy to basically leave it alone, and the consequences are high for a spill. So it's that kind of, we go into a system, we figure out role allocation, like what's the best thing for the automation or autonomy to be doing? What strengths does the human have? What weaknesses do both of these have? And then we try to build a system where the human is providing the backup for the weaknesses of the autonomy, and the autonomy is backing up the human.
This is so interesting. And actually, it's so interesting. I didn't even know vaccines were grown through fermenting. That's a whole surprise to me. I'm really curious, when you say every little one of them can have a different process play out. Why do you think that is? Like, what's different from one to the next?
And this is where your guess is as good as mine. And so when we were working with Pfizer, we actually they had older versions that they then replaced with newer versions. So we got to see them put in brand new units, exactly the same, at least per the manufacturing standards. And immediately they all started having different personalities, the brand new ones, right? So, and in theory, and that's actually the thing that I think this is where model-free estimation is very helpful, because we just can't figure it out. We don't know whether, if there's some specification of some valve inlet, if it's just maybe, 0.01% difference, is that enough to cause it? I mean, because and this is the reality of real world manufacturing, that you've got maybe all these tolerances everywhere. But it also goes to cell growth, the growth of cell cultures, like, cells do whatever they want, and we kind of know how they work, but we also don't have a full appreciation for the cell growth process and, how they're interacting with each other and potentially driving that same process.
I really like that you are, as you do your research, you go into the real world and try to really understand what's happening there, what's missing, and bring it back into your research activities. And recently you did a sabbatical at Amazon. Can you say a bit more about that? What did you see there, and how has that inspired your research?
Working with Amazon Robotics was really great because I got to see how robots and people, how the world is changing in terms of manufacturing. So up to now, not just even in warehouse manufacturing, but in automotive production lines, many, many different factories, there have been zones of exclusion. Robots are in one area, humans are in another. And for the longest time, that guarantees safety and not completely, but for the most part, those you can have good, nice, safe operations that are highly predictable. But unfortunately, to be able to completely automate some warehouses, which, by the way, I would love to do, because, it's no secret that Amazon has experienced increased incident and accident rates of its workers, and their accident rates are higher in the robotic warehouses. So, then that raises the question of like, okay, well, even if you think that you can fully automate something, it's harder than it sounds, and especially in these areas of unstructured interaction. So, we can have robots move goods around in maybe safe areas where there are no humans. But if you really want to get the economies of scale up, you're going to have to start having humans and robots work in the same environment. And that's when that uncertainty goes way up. So I learned a lot from Amazon about the real world nature of these problems. I also learned a lot about standardizations and how we might need to rethink the way that we have standards. We try to adhere to them, or maybe they're put upon companies by different governments, but that creates some problems when the technology is far outpacing standards. And so I still think there's a lot of work to be done in rethinking the development of standards, because right now I really do not see a set of standards that I think are appropriate for unstructured human-robot interaction. And so I think there's just still so much work to be done. And that actually takes a lot of research.
Now, of course, Amazon has multiple types of robots. There is mobile robots that transport things, and there's manipulation robots that do what we would do with hands effectively. Do you think it's very different what to think about between the mobile robots and the manipulation robot?
Generally, the issues are similar, although the manifestation of them are going to be slightly different. Mobile robots where you're moving item A across a warehouse is going to be different than if you're picking up a different item B and maybe handing it to a human, right? There's proximity issues, there's speed issues, whether or not, what's the actual physical extent of damage that could be done? What are the failure modes? I mean, failure mode analysis is really changing. And I would like to see, including myself, do more research into understanding how can you help companies and engineers understand what the scope of failure modes can be without having to rely on historical evidence to show you what's likely going to happen.
Now, Missy, one of the things that I saw you've been working on recently is essentially looking to transform aerospace autonomy education and research. Why do we need to transform education and research in aerospace? What's going on?
Yeah, you're really starting to get me on one of my Don Quixote moments where I'm going to tilt against a windmill. I do a lot of tilting against windmills. It has become clear to me through all my work in the self-driving community and also the drone community that there's, and to be fair to academia, we are all sort of Pavlovian trained for success. We have to have successful algorithms. We have to have successful vision systems. We're always trying to succeed and maybe, do 1% better than somebody else on the ImageNet, for example, right? So we're in this competitive race to do better than the next guy or gal. But what we don't do is we don't sit back, and we're not that good about assessing our technologies or assessing our algorithms. Indeed, that's not really, we're creators, we're not assessors. And I think this is one of the reasons why, if we look back at the DARPA Urban Grand Challenge, just the grand challenges and then the urban grand challenges, there's all this push to improve systems, but significantly less effort and certainly no publications that come out to tell you, here are all my mistakes. I made this mistake and that mistake and this mistake. So we don't ever really talk about that publicly, even though around the bar, if you go to conferences, that's actually the funnest part about going to conferences is hanging around with people who will actually, after they've had a couple of drinks, they love to tell the stories about, all their disasters. For every successful professor's robotic YouTube video, there's about 1,000 hours of failures behind that video. And we just don't talk about that. And so it's become clear to me that we're not good at assessing our own work. And then when we deliver these technologies in some way, shape, or form to industry, and, these technologies with heavy statistics underlying them, it's very difficult if you're not in the business, it's just not, I had a professor once tell me, nobody ever really understands statistics. They actually just get used to it. And I think that there's a lot of truth in that you have to spend your whole life. I mean, I really only feel like now as a full professor, do I really, I'm really fully understanding to the extent that anyone can fully understand these systems. So we have this problem where there's no culture of evaluation and assessment. And that culture needs to go hand in hand with the growth of autonomous systems. Because like you said, by the way, there is not a convolutional neural net ever that can give you 100% accuracy. And we shouldn't expect 100% accuracy. You asked me earlier about, what is good enough? It's going to depend on the domain. It's going to depend on the use. There is no magic answer for, I don't ever believe that any system should be 100% correct because humans are never 100% correct. But for example, when a pilot gets certified by an FAA inspector, they sit in a check ride for an hour, just an hour. And the FAA inspector will throw some emergencies at them in the simulator. They're kind of a random sample just to kind of see what the pilot's thinking. And that builds some kind of confidence in the FAA inspector that pilot should be then allowed to do a commercial aircraft. We're going to have to find something else like that. Again, this goes back to assessment and evaluation, but academia is failing on this. And so in this study that you're talking about, we went out and we interviewed department heads from all these aerospace departments and asked them what they thought people should be teaching, what they should be teaching. And then we asked industry and government what industry thought academia should be teaching. And it's a pretty hilarious comparison because they're not at all aligned, right? So industry wants us, industry and government want safety, certification, testing. They're like in their top 5 of topics. And those topics are in the bottom third of what academics think we should be teaching. And again, I think there's some cultural misalignment. And I get very angry with the National Science Foundation, who refuses to fund anything in safety. It's almost as if you got the word safety in your proposal, it's definitely going to be rejected. And because it's not seen as a real science. And it makes me mad because I actually think there is a huge safety of science that includes statistics and social science and ethics and policy and engineering, right? We could go on and on. I think science is the science of safety is the perfect interdisciplinary pot that you could throw everything in. Unfortunately, the National Science Foundation doesn't see it my way.
We are dropping new interviews every week, so subscribe to The Robot Brains on whichever platform you listen to your podcasts. One of the things when I was looking at your recent work that really also struck me was your notion of subjectivity in the creation of machine learning models. Now, of course, there's a lot of subjectivity in what we do in creating machine learning models, in that we tune hyperparameters, we choose the size of the network, and so forth. But I think you're getting at something deeper there in terms of how they then get used beyond just the fact that we make some various decisions. Can you say a bit more about that?
Yeah. So, I'm old. I've been in academia now 20 years. So that qualifies me as an oldie but goodie, I think. And I've been doing various forms of AI for a long time. And I also look at human behaviors. And so when AI through Jan and Jeff Hinton, when that really took off in that way, I was actually just kind of mystified, because I've been doing this for a long time, and I know that there's actually quite a bit of subjectivity in what people outside the business think is a very objective, the math will speak to us, the numbers will tell us the truth, it's the matrix. And, I'm just like, oh my God, we're making all kinds of choices that we're not even sure what that how those choices affect the final outcome. So then I actually was able to get some funding to do research in this. And of course, that's actually the critical element, is what can you sell to somebody as an interesting topic? So, we did this research looking at, well, what happens if you take this data set and analyze it in all these different ways, and how would that affect your outcomes? And it was just an example. So to help people get their head around, when you talk to AI researchers, they'll be like, yeah, I guess we are making a lot of choices. And sometimes we do sensitivity analyses, but most of the time, not really. And we're certainly not querying whether or not our choices really have a big effect. Indeed, we don't want to know in a lot of cases, because we don't want to know that there potentially is a problem in our system that could cause us to lose another year in doing research. So the book I want to write is like the new structure of the scientific revolution. I'm trying to think about what should that be like, and how should we think about, we as researchers and developers, how do choices that we make actually end up propagating through a technology? We've got a really interesting study going on right now, is that we're looking at the quality of data labeling. So these are, again, just, we've got people tagging images, and we're trying to figure out right now how the subjectivity in human data labeling, and indeed even some of the automated data labeling that exist out there, which when you hear automated data labeling, you're thinking, oh, well, that's very objective. Well, not exactly, because there's going to be some bias that shows up in that system as well. So stay tuned, because we're going to come out and tell you if and where and how much, and is it really something we should be worried about. But I think that I would really like the AI community to stand back and at least recognize that beyond the data bias, the bias that shows up in data sets, which I think, has gotten tons of airplay, there are other ways that we can introduce bias unexpectedly in these systems.
Can you make that a little more concrete, how that bias would present itself, the one that doesn't come from the data? Yeah,
so we in this paper that you can get on our website, we took this transportation data set that's a very well-known transportation data set, and it's got 1 million data points in it. And then we showed how, if you use one kind of model, a simple model like logistic regression, or then you decided to do a neural net, but then feature engineering inside neural nets is a whole nother ball of, that's a whole field of study that's starting to emerge, is how do you know in these gigantic databases how to down select to the most meaningful features. And that's an art. That is not a science. And so we basically went through and showed, okay, well, if you made choices in these different ways for these 4 different models, what would the outcome be for this transportation data set? And this, in real life, this transportation data set is used by departments of transportation around the country to determine what they think are the most important predictors for accidents. So we showed that in these 4 different models, that the top 5 variables that you would think would be the most important, highest predictors were not the same across the data sets. And in some cases, not even close. And that has real practical value. And I think the number was somewhere around $4 million, where we showed, like, you know, if you chose this, if you said you thought this one data set was better, that this one model was better than the other, and you made your funding decisions based on that, that could potentially cost you $4 million that was wrong, because maybe this other data set is more closely approximates the truth. And then that's actually a whole nother question. It's like, how do we even know what approximates the truth? And how do we get at the truth? And that's where we need to get into some subject matter expertise. And I think that it's hard, because the truth in this world of fake news, it's not clear what the truth is. And the lens that a stakeholder is looking at the data set will change their interpretation. I'm not claiming that there is a one right way, but I think what's important is that people realize that their chosen modeling approach, and in fact, I've got, as you do, tons of students in the real world, right? And when you ask them what kind of modeling approaches they're using in the real world, almost always they're using what you taught them, right? So they learn something under your tutelage, or even worse, they learn it from the guy that or girl that sits next to them in the cubicle next to them, and they've learned some hack method to do some kind of prediction, and then that's what gets used. And if you ask them why, they don't really know why. They just know they do, because it's something that they're familiar with. And I think that we need to stand back and really examine it's almost like therapy for ourselves. Like, why do we make the choices that we make, and what kind of impact would that have?
I fully agree. It's interesting to always question what we're doing. And part of what I'm hearing in your description of kind of what's maybe going wrong in some of the uses of neural nets or other models is actually quite related to the other things you've talked about. Because what I'm hearing is a neural net is being trained, or maybe another model is trained, but often it's neural net these days, of course, and is being trained. And when you train it, well, the only thing you really tell it to do is to pattern match from input to output in at least supervised learning, and you optimize for that. And it does a very good job at that in many scenarios these days. I would say as a community, we've really figured out how to drive that training error down to zero, and often even holdout error from data from the same distribution also going very low. But then you're describing people taking that model and actually not using it to make a prediction on the same kind of data, but do something completely different with the learned model, like removing features from it and somehow using that to make decisions, which it seems like there's this big kind of almost like, again, human-machine interface mismatch, where the machine was built to drive down error in a certain situation, but then somebody starts using it for what it was not designed to do.
And so let me give you a real world example that happened today. I was flipping through my Twitter this morning, and the US Airforce is claiming that they now are guiding their bombers, a set of bombers, based on AI. So that always makes me dig deeper. And so what it turned out the Air Force was doing is that they have a simulation of the world that a B-2 bomber, for example, would fly over. And they applied some machine learning model on potential targets inside a simulation. And then lo and behold, they get a really great high accuracy, and, the machine learning models can pick out targets way better than humans. I mean, that's what they're claiming. And, with the then extension that, we should have the machine learning do our bombing missions as opposed to human. And then, as if that weren't bad enough, then they claimed that now we're going to be able to take this simulation and extend all of these results to all these other aircraft and all these other missions. And I'm just like, this is why people get scared of AI, because entities like the Air Force do not understand that when you train all of this, you train your models on simulated data, the only thing that this can ever generalize to is the simulated data. Right? It's not the real world. It's not picking out targets in the real world. And even if you did you did this on real world data, it would only be good for that part of the world or for exactly that environment under exactly those conditions. And so I do worry about the military because I think that there's a lot of pressure. The Russians are always hacking us. China's going to Mars. I think the military feels a lot of pressure that they've got to show really cool AI results. But when they do stuff like that, it makes me realize that they really do not know what they're doing. And you should never try to generalize simulated data to the real world, especially you talk about time critical and safety critical. I mean, we're talking about dropping bombs. You would think that this is the one area that you should really be very sure about what you're doing. And so if you think I'm on Elon Musk's case, trust me, I'm always on the military's case as well.
You should be very cautious about any expectations on generalization from what you train on. The data you train on is going to determine how well it's going to work on data you put into the network. And if it's very different data, it's unlikely to work very well. Now, I might maybe highlight one somewhat of a counterexample to this, not for the specific scenario, but one of the recent advances that have really struck me as surprising is if you train in simulation for robotic manipulation, not for safety critical application, if you train in simulation, yes, the simulation never matches the real world, so it tends to not work all that well. But then if you train in simulation where you have many versions of the simulator, and if you're able to train a control policy that works across all versions of the simulator consistently, then there's a high chance it might also work in the real world because you've effectively discovered a control strategy that is very robust to many variations, and then maybe has a pretty good chance in the real world that at least in our case, worked well for essentially identifying where objects are on a table, or in the OpenAI case, worked well for in-hand manipulation of a Rubik's Cube, where training on the actual hand would be super expensive. But training in simulation is cheap. And so it seems like there's something even more subtle going on, which is you can generalize sometimes, which I guess builds confidence in the fact that maybe you can rely on the simulator, because sometimes you can if you do it really right and under the right circumstances, and when you maybe don't need 100% reliability, but in many cases you cannot. And so it's a very kind of subtle conversation when to expect generalization.
I totally agree with you. I think simulation has its place, and indeed, it just would be cost prohibitive to try to do much of this development outside of a simulation. I kind of think about it if you cross your hands in an X, right? I actually think about that simulation is super important at the beginning of the development. But then that should go down over time as you start to get closer to real world development. And then your real time applications should then kind of ramp up, to balance out your dropping off of simulation. So simulation is critical, I think, for especially early stage research and development, and especially for the actuation components that you're talking about. In the Air Force case, I talked about, this was just purely vision, object recognition. So that's not an actuation issue. But yeah, I think simulation is important, and that's why I hate to, I don't mean to sound like, all simulation is bad, except that we have to realize at some point you got to get those training wheels off. And then the training, then you have to let it go in the real world. And I mean, I'm preaching to the choir. As soon as you put it in the real world, you're just like,
things become a lot harder.
It's so hard.
You'd hope though, with the bombing target scenario, that hopefully they would go out and extensively test in the real world, not by dropping bombs, but by just collecting real data and getting verification on how well it works. This is actually a topic you've been pretty engaged in more generally. This notion that, in some sense, that maybe that AI is becoming ever more important for the future of warfare, because of course, if it can make decisions, sometimes it can make them faster than humans, and it can see more data than any human can see, and so forth. So you've been talking about it being really important for many reasons for the future of warfare, but also that there's actually some real struggles in actually doing it right, and a real gap in what's being done in the military versus what's being done in private. And I'm curious, like, why does there have to be that gap? Why can't we bridge it?
So is the question, why can't we bridge the gap between the civilian world and the military? Or why can't we bridge the gap between bad AI and good AI in the military?
Actually, I'm curious about multiple things. Maybe the things I'm most curious about first is, what are even the roles of AI in the future of warfare?
Trying to figure out where and how and when you should put AI into a military system. I still think this is a topic that the Department of Defense struggles with. I think the CEOs of defense industries and even senior generals and admirals in the military, they see AI as this killer app. Like, if we get AI in system X, it's going to somehow bring us all these new capabilities and we're going to be amazing. And they don't really realize that AI may be an enabler, but it's not actually the savior technology that's going to revolutionize how they conduct warfare. Indeed, it could actually cause a lot more problems if not used correctly. So I think that one thing that we know, and this is the issue, the main number one, if I could just condense it down to what do I think the military doesn't understand about AI, is that for the most part, AI really struggles under uncertainty. So if you've got some system that relies on AI and it sees a set of conditions that it's never seen before, that is high uncertainty, and we're not going to be sure how the system is going to behave. The military, I mean, I've been there. Every mission I ever briefed never happened like we briefed. So you sit down, you say, okay, I'm going to do X, this is going to happen, then I'm going to do this, and then you're going to do this, and then we're going to do that. It never happens that way, right? Always something happens, something breaks down, somebody screws up, somebody didn't get to the range on time. It's always just putting out fires when you're in the military. So this is the fog of war, right? So I worry that the fog of war kind of combined with AI's inability to handle uncertainty is a problem. So then you ask, well, where should we be using AI? AI is good in those narrow applications where you can kind of at least bound the uncertainty. And so for the most part, people who are in the know inside the military feel like the logistics applications are good. Doing the image analysis that's not time critical for, maybe analysts who are trying to figure out, if there's an Iranian terrorist boat coming in and out of port, maybe watching those images over time, AI can help you figure that out. But what AI summarily should not be used for is anytime you need dynamic adaptation under high uncertainty. That's just a big no-no. And it gave me a heart attack a couple months ago when some general said, oh, we're going to use AI in missile defense, ballistic missile defense. I'm like, oh no, I'm moving, because that is the absolute wrong time that you would want to use AI. But, in his defense, he just doesn't know. And this is a bigger problem that I think the Department of Defense has, indeed the entire government. We do not have enough people who understand AI and who can speak intelligently about AI in all levels of the government, but especially in the senior levels of government.
It's interesting you say that, because, I would imagine they would want to know more about this and would want to understand this. So, do you have any thoughts on how we can reach them and kind of educate them on what AI can do and not do today? Maybe they should come listen to this.
Yes, they should listen to this. I was recently on the Defense Innovation Board, and that's what the Defense Innovation Board, it was chaired by Eric Schmidt. It was all these grand poobahs of artificial intelligence on this board. And, we were trying to help guide the government down a better path. And so it's not that they're unaware. They are aware. I think that though it's difficult for them to appreciate the breadth and depth of the problem. And, and indeed, this is why, there was recently DARPA, the Defense Advanced Research Projects Agency. They put out this cool, sexy video that kind of showed how great they were in AI. So it's called Offset, and they had swarms of little ground robots, in theory, working with swarms of UAVs. And they were trying to show just how awesome they were, just how great US military capability is in the AI space. And when you watch the video, it's kind of funny because as soon as they start to pan the cameras around this combat town world where they've got everything, there's gigantic QR codes everywhere. And you're just like, you cannot conduct war with gigantic QR codes everywhere. And indeed, this really bothers me as a former military person. You just communicated to both the Russians and the Chinese and North Korea and everyone else just how incapable we are if we have to have giant QR codes on all of our entities to be able to navigate these systems in a war environment, right? And so it's exactly that. I have been on this tirade for years trying to get the government to understand that it doesn't, it's these are actually the known unknowns. We can't even forget the unknown unknowns. We don't even know what to do with the known unknowns because we've got one agency who's supposedly the most advanced research agency putting out videos that make it look like a freshman project at a university. So I think that it's not resonating. People are not getting it. I'm constantly working with the government. I'm on many other advisory boards. We'll see if they eventually get it. But if we don't get it soon, what will happen is something will happen in the military space, and it's already happening with cybersecurity. We're clearly becoming vulnerable in areas that involved a lot of software. And that's only going to continue until this country starts putting more money into it.
No, I'm worried about that, what you just said. And I'm wondering, like, how can we do better? Because, clearly some of the best AI research is happening in the US, not just in the US, but definitely the US has a lot of the best AI research going on, and both in industry and in academia, breakthroughs happening on both fronts. And then, at least in academia, we often meet program managers from ONR, Office of Naval Research, from DARPA, and so forth, from Air Force. And in fact, many of the program managers I meet are extremely knowledgeable in the space. They're constantly listening to the latest progress and so forth. But then somehow, I guess from there, it doesn't connect all the way back. Because when I'm talking about program manager, they'll just say, "Oh, yeah, but have you also seen this paper?" And really have an in-depth discussion on the work that we're doing. So somehow after that, there is some disconnect where that doesn't really go all the way.
Yeah, I totally agree. Some of the smartest people I know are program managers inside various government labs. And indeed, those program managers have really inspired a lot of my research and helped me understand real problems and how it really affects the military and just the government in general. So and that's why I said, there's mostly a workforce problem. There are these handful of people, but those handful of people are generally seen by the military acquisition system. I mean, their research, they're not doing the real thing. So even the guys who really know, the guys and gals inside the military who really know what's going on, are kind of marginalized. What we don't have is like a central government effort in artificial intelligence and how we're going to, create it, compete it. Like, how do you actually coach companies to develop the AI that you need and then test and evaluate it, right? So we're just missing those senior managed layers of capability, and the research managers are doing all they can, but they have really nothing to say about how a technology comes out of the research. I think academia is doing great. We're firing on all cylinders, but like you said, there's some kind of gap. I call it the Grand Canyon between, all the great research that we're doing in academia and then transitioning it somewhere useful. I think there's, we don't have enough time here today to go into all the reasons, but, there's a disconnect with industry. Boeing, Lockheed Martin, Northrop Grumman, they don't have any capability in this space, but they're going to pretend like they do. And so, they kind of just keep the hype cycle going. And why don't they have the top talent? Because none of my students want to work for the defense industry. All of my students, like your students, want to go to Silicon Valley where all the cool stuff is happening, right? So I think that is something that this country needs to appreciate. Look, why would I go work for a defense contractor and make tiny money and, have to deal with all that bureaucracy when I can go to Silicon Valley? And when you land at SFO, you can actually feel it in the air. You just feel the energy, and you go down, all the startups and the excitement. That's where young people want to be, right? I totally get it. So why would you ever want to go to the stodgy defense industry that takes forever to have some cool technology come to market, if it ever does come to market? Whereas you can see your ideas go from paper to a thing that somebody's holding in their hands in 18 months in Silicon Valley. Mm-hmm. So I do think, and the government's trying, right? They have the Defense Innovation Unit and Silicon Valley, the Defense Innovation Board, but we were all recently fired when Biden took over. So, and they're going to recreate it.
Something new coming in place instead?
Well, maybe, we'll see. I think it's all up in the air. But I think there's something called the Joint AI Center that in theory is at the Secretary of Defense level for this country. And so they're kind of doing the right thing, but in all cases, there's not enough money, and the government has to rethink what it means to attract talent in this space. Whether or not, I think we just need to hemorrhage money into the universities for computer science. I mean, computer science, I believe that we just need to beef up these programs. Computer science needs to become like English. It's kind of a language. We all learn it. Not that everyone has to be, a hacker level, Russian level hacker, but at least has some level of familiarity with what it means to code, what it means to compile, for example, what are all the problems. Cybersecurity is another issue that this country, if we do not do something soon, that is going to be, it's already becoming a huge problem. And we're not putting enough people, and whether we may, pay for college if you do 2 or 3 years. It's almost like a new kind of Peace Corps, the Computer Science Corps, right? I believe that computer science should be free at all community colleges in this country. Anyone who wants to take a computer science course in America should be able to do that for free at a community college. So, these ideas, you can just hear the dollar signs going on in the background of everything I say. But until we actually make a pivot like that and really make it clear that we understand that computer software is here to stay. And unfortunately, the defense industry treats it like a free add-on instead of its own dedicated field. And until we make that leap, we're still going to struggle.
Now, one of the things that really strikes me about the earlier conversation, what really strikes me about the notion of educating the military is when I think about people working in the military and that we would like to educate, they have put their life at stake. Almost everybody there has put their life at stake to protect the country and so forth. And I got to imagine, I mean, you've done that. I mean, that's a very different feeling when you've done that. And could there just be maybe a gap in that regard that, when you are somebody who's put their life at stake to defend the country, defend the person effectively that you're now talking with, who's trying to educate you on something that might just be maybe somebody who hasn't put their life at stake has a harder time earning their credibility in a conversation. Is that possible?
Yeah. I mean, I think I probably get more outraged over elements of AI, for example, that other researchers are why is she so upset about this? And it is because, look, I've been there, and I've worked with systems that were terrible, that some engineer, or some company sold a bad bill of goods to the government, and then I was left holding the bag as an operator, where it could potentially cost my life. So putting technologies in the hands of people that are defending our country, but also, and I do take it very seriously, like, fighter pilots, they're legalized killers. That's what your job is to do. And we ask a lot of people, and fighter pilots, people on the ground, we're asking them to do a job that most of us don't want to do, but we kind of agree that needs to be done. Yet we put all this subpar technology in their hands. And then we wonder when, for example, we get friendly fire accidents. We're like, well, that guy's awful, but we were yet an awful infrastructure that did not give these people the tools that they needed. So I do think that I take it probably a little bit more personally than other people do, or maybe that I should. That being said, I have been advocating for a long time that the military start embedding engineers, academics on the front line, or as close to the front line as you can get them. Because I think that it's, you have one vision of what war looks like from movies, and it isn't at all like that, right? So I think that most people, if they, the embedded engineer concept, if you got the opportunity to go and hang out with people, like, for example, we could put a whole bunch of engineers on an aircraft carrier. They're not going on the missions, but they get to see the fighter pilots when they come back, and they can see the exhaustion, and they can see the frustration, and then they can potentially even see the tapes, because everything's taped, that you go back and you play it over. A picture's worth 1,000 words, right? That experience is worth so much. And so I would love it if we could give people in academia, and even, in companies, obviously, more experience to see what it's like, because I think we would end up with better systems.
That totally resonates. And when I think about, computer science, I also think of it as it's like an extension of yourself. If you understand how to program, you can let the computer do a lot of work for you. And AI is kind of the next extension of that. If you understand AI, you can build systems that can do a lot of things for you, right? Which is so powerful compared to just learning something you're going to be doing then everything yourself all the time, whereas just you doing it. So yeah, I'm also supportive of trying to get as many people as possible access to that education. It is kind of fortunate that a lot of us put our courses online, right? And so self-motivated people anywhere out there pretty much can go online and find courses. And of course, it's harder to study on your own and not with the guidance and so forth. But at least I think most educators do a lot of effort in making things available for anybody to just watch videos and do homework on their own.
Yes, but as you and I both know, until your feet are held to the fire, especially when you're young, you probably, you don't put as much effort into it as if you knew you were being evaluated. And so, I think COVID has opened the doors to helping us understand that there are different ways to educate people. But I mean, the vision that I have for computer science education is K through 12. I mean, it's not just college. Yeah.
Wow. Okay.
Yeah. I mean, we really have to appreciate that moving into the future, coding is it's another form of communication. And, there's a lot of resistance at a lot of universities to change. If we don't start doing something immediately and, with purpose, then we're going to continue to not have gas, not have power, not have meat, not have, whatever the hackers decide they want to take away from this, they'll be able to do easily.
Now, one thing that I noticed is you recently also included in your research agenda cybersecurity specifically. But generally, your focus is on human-machine interfaces. So how does that, bind together?
Yeah, no, I think it's a great question because, I talked a little bit before about fashion trends in research. And if I actually look back at my own career, I was at MIT for 10 years, and the thing that people knew me the most then was all my work that I did in unmanned aerial vehicles, AKA drones, right? And I was one of the earliest researchers in that field. And then Jeff Bezos decided to commercialize, with Amazon Prime. And I'm like, I need to find another research field to go into when somebody starts to be commercialized. And so I and at this point in time, I had been working with the Urban Grand Challenge teams. So I knew what was coming so I kind of slid over into the self-driving world to really, get a traction there. And, apparently I only have about a 10-year limit on my attention span for whatever new field that I'm in, because it's been about 20 years, right? And so now I'm like, okay, I got caught up into that gas line debacle, like a lot of people did. I'm like, that is it. I am doing something about it. And so I'm teaching a new course in the fall called The Human Element in Cybersecurity. And, I'm pivoting a little bit, obviously all the lessons I've learned in the other areas, a lot of it still applies. But, I also believe I do a lot of complaining as I've just basically raked everyone over the coals here. It's amazing that I ever get any funding from the government as much as I give them grief, but I think they appreciate it. But, I want to get into another area because I think that this need is so huge that I just can't complain about it anymore. I need to help do something about it.
And when you think about carrying over your prior expertise, of course, you'll be learning a lot of new things in the process, but the human factors part, how does human factors play a role in cybersecurity?
So the area that I'm really looking into right now is deception. How is it that we are deceived? How do we deceive others? And are there ways that we can, and I'm actually using some machine learning modeling to start thinking about modeling the way that people interact in the world to understand where points of vulnerability are. So, we're doing research in terms of where can I stop people from being deceived, for example, like phishing, or where can I deceive people? Because, to really know how to fix this problem, you need to get inside the head of hackers, right? And understand how deception happens. So from that perspective, I'm really focusing hard right now from a research perspective on the deception component, both the prevention of and the doing of.
If we kind of zoom out a bit on your activities and kind of what you're most vocal about in AI, it's probably pretty easy to perceive you as somewhat pessimistic on AI and so forth. And I'm kind of curious, are there any things that might have surprised you in AI where maybe things moved faster than you expected, things worked better than you could have expected, rather than feeling that things aren't good enough?
Yeah, I know. I'm hard to please. Just ask my students. First of all, I want to say I am just blown away that we are even having the arguments that we are about self-driving cars. If you'd asked me when I was a baby academic and I had first got my PhD, I did not think we would be at this place at all. So I actually think it's phenomenal. And I'm very appreciative of the fact that the self-driving car companies don't realize this, but what they've done is they've really paid for a lot of research without realizing it's research. They thought it was development, but it's actually research. And so I am so in awe of, Waymo, and even Tesla's. Like the fact that we can do what we can do at this point in my life, I did not think that we would see engineering move this fast. So as much as I can, get on everybody's case, I am still in awe of the technology. Mm-hmm. I also, the most recent element, other than the pottery that I was telling you about, the one use of AI that I also really love that I think has it's just tremendous applications is the robotic nose, where we've been using AI to figure out how to detect sense through quote unquote smell. We still don't understand how humans smell. We don't know how dogs smell. We don't, we have some vague notions, but we really don't know how to replicate smell. But it turns out machine learning is a fantastic application, and we're having much better results, with using AI for artificial noses than some other previous old school signal detection approaches. So I am very optimistic and very positive about the technology. And I'm so excited that one of the reasons I became an academic is I love that my students teach me something every day. And then you said, oh, you're going to learn so much in cybersecurity. Yeah, that's right. I'm a lifelong learner. I'm extremely curious. It's to a fault. I'm extremely curious. And so I am very positive and optimistic that we are going to continue to open doors. So on that front, I'm all in. But I also, as a former operator of, highly advanced systems, that's when, that part of me puts the brakes on and say, hey, there's real people at the end of the line here, and we need to make sure we're designing technologies the best that we can.
As you think about the future of AI, and especially humans and machines, what's your vision, and what are you most excited about for the future?
I'm a single mother. The thing that excites me the most about the future of AI and robotics is to have a maid. That's if I could have one technology, forget the self-driving car, I want a robotic maid. And indeed, if you actually go around, and I give talks around the country, the robotic maid is the number one request from men and women in the general public. That's the kind of technology that they see. Beyond getting Rosie the robot from the Jetsons, the thing that excites me the most is when I talk to people, when I talk to other academics, I talk to CEOs, even just your average person in the public, and I explain to them how important it is to consider the human-computer collaboration, the bringing of these as a team, and that the real future is not in replacing jobs, but actually doing all new kinds of job collaboration where humans and computers / robots / AI work together, and then seeing the light go off in their eye. I love that. That getting the aha moment out of someone to make them understand that it's not job replacement, it's job augmentation. To me, that's the most exciting thing about my job.
That's so wonderful. In terms of the maid robot, that's something on my list of things that I like my research to contribute towards. I hope I can help you out in all of us getting there. We'll see. Hopefully soon. Do you think it might be there soon? If Rosie the robot saw my daughter's room, talk about the massive unstructured mess. Okay, so we'll leave my daughter's room to be the final test for Rosie the robot. But I think that we'll see some improvement. We already are. Robots are getting more capable, and all the vision work that is happening in the self-driving world, eventually, a lot of engineers are going to be looking for jobs. And so I think the great part about that is that they're going to spill out and move over into other domains. I think there's a lot of exciting movement in construction right now. And I think it's having, construction domains are a little bit more unstructured, but they have some structure. So we'll see a big push in robotics in that space. And then eventually we'll start to, make more and more advances that will get there. So, I don't think I'm going to get Rosie the robot made tomorrow, but you never know. I could get some technologies that, how about that painting robot that instead of me having to hire painters to come in, I could just put a bot and it goes crazy and it does my whole house. Maybe that's, I think we'll have more narrow applications first before we have the robot that can do everything. Got it. Well, Missy, this was such a pleasure. I learned so much. I'm so impressed with the range of things you've been able to make progress in, and spanning both advocacy and fundamental research. It's absolutely amazing. Thank you so much for joining us here.
Thank you for having me. It's been great hanging out with you.